Moving on to the next example, so you have 500 meters of fencing to divide a field into 3 equal sections as shown here. Express the total area as a function of width, determine the domain and range, and then what dimensions will give a maximum area. So the first thing you want to do is always draw a diagram if you're not given one. In this case, we were given a diagram. And you want to label the sides. So let's label the long part of the field as L, or the length. And let's label the shorter side of the field as width. Now the fencing is everywhere where you see these black lines. So the fencing has to be used around the perimeter of the field and in these 2 spots in the middle to divide out the sections. So that means that each of these fences has a length of W as well. And then this length of the fence is also L. And since we only have 500 meters of fencing to work with, we know that the 500 has to be a total of all of these lengths and widths. So we got 2 lengths, so this would be 2L, plus 4 parts of the fence that have a length of W, so 4W. Now we can also simplify this further, this constraint further. We can factor out a 2 from the right side and we'd have L plus 2W equals 500, and then dividing both sides by 2, we'd have 250 is equal to L plus 2W. So this here is our simplified constraint. So this is our constraint. Now what's the first question asking us? We have to express the total area of the field as a function of the width. Well, since this is a rectangular field, we know that the area of the field is equal to L times W, length times width. However, they want the total area as a function of only the width. So what we can do is we can take our constraint, we can isolate for the L and then sub in that L here into our area function, and we'll have an area function in terms of width. So isolating for the L, bringing the 2W over, we would have 250 minus 2W is equal to L. And then we take this L from our constraint and sub it in to our area function. So area would equal, instead of L now, we're going to write 250 minus 2W times W. Now I say that we take this function and we graph it. So we know that the area is the dependent variable and the width is the independent variable. And notice how this is a parabola. It's just in factored form. So because it's in factored form, let's find what the W intercepts are. So we set A equal to 0. And we have to solve these. So this here, we know that W is equal to 0, so that's one of the intercepts right here. And then we have to solve this bracket. When does 250 minus 2W equal 0? Well, if we isolate for W, we'd get 125. So this would be the other intercept. Now the next step in graphing a factored parabola is finding the coordinates of the vertex. So to first find the W value of the vertex, we would take the intercepts. We would find the midpoint of the intercepts. So we take the intercepts, add them, the 0 and 125 divided by 2, and we would get a W value of 62.5. So we know that the vertex is going to occur at a W value of 62.5. And then to find the A value of the vertex, we would just take the 62.5, plug it into our function for W, and we would get a final value of 7,812.5. So we know that the maximum, or the vertex, would occur at an A value of 7812.5. I'll write it here just to make it more clear. So the coordinates of the vertex would be 62.5, which is the independent variable, the width, and the area, or the dependent variable, would be 7,812.5. And now, since we have the diagram, it becomes a lot easier to answer the rest of the question. So just to make sure we don't get off track, question A we answered here. This was our area function in terms of just width. So determine the domain and range. I'll answer them here. So the domain, looking at our graph, we can tell that the width can only take a value between 0 and 125. If it's anything above 125 or less than 0, the area would be negative, and that doesn't make sense. So the width can be anything, but it has to be between 0 and 125. And our final question C, what dimensions will give the maximum area? Well, we know that the maximum area from our parabola occurs at a width value of 62.5. So we know that the width is 62.5. Now, what about the length? Well, to find the length, we can use our constraint. So plugging in our W value of 62.5 into our constraint here, where L is equal to 250 minus 2W, if we plugged in 62.5 for W, then we would get a length of 125. So the length is 125. So there was a lot that went on in this question, so let's do a recap of what we did. So we had 500 meters of fencing, and we had to divide a field into 3 equal sections as shown here. So we labeled the length of the field as L and the width of the field as W. So now what we did was we took our constraint of 500 meters of fencing and made it equal to each part of the fence in this diagram. And then we simplified the constraint and got it down to 250 equals L plus 2W. And we have to express the total area as a function of width. So we took the area of the whole field is equal to length times width. And since it has to be in terms of only width, for L, we substituted the constraint of 250 minus 2W. So we answered question A. We have the area in terms of just the width. And to answer B and C, the domain and range and finding the dimensions that will give the maximum area, we decided to graph it. So since the parabola is already in factored form, it's easy to find the W-intercepts of 0 and 125. And then once we have the intercepts, we can find the vertex by finding the midpoint of the intercepts. That would give us the W value of the vertex, which was 62.5. And then plugging 62.5 into our function, we got the dependent variable value of the vertex, which was 7,812.5. So then the domain and range of this function was that the width has to be between 0 and 125. It can't be anything outside of that range because then the area would be negative. And then the range, which is the values the dependent variable can take, or the values that the area can take, the area has to be between 0 and its max value of 7,812.5 meters squared. And then what dimensions will give the maximum area? Well, we know at a width of 62.5 meters, we would get a maximum area of 7,812.5 meters squared. And then to find the length, if the width is 62.5 meters, we can just plug in that W value here in the constraint, solve for L, and we get a final value for L as 125 meters.